Hello, everybody. Welcome. It's the 9th of July, 2024. This is the Open Research Institute's FPGA Meetup. What we do is we talk about what we've done over the last little bit, usually a week, what we have planned over the next week, and if we have any roadblocks or if we need any resources. So Matthew cannot join us today. That's November Bravo 0 X-ray, or NBOX on Slack. And so he's been working on the minimum shift keying modem development, and he has some updates. So I'll just go ahead and read them in. The modem FPGA builds are working and can be loaded onto a Pluto. So the Pluto SDR is the target for this particular FPGA implementation. The initial FPGA had register read issues, and there was no way to confirm the modem operation. A PRBS module. So this is a pseudo-random, I believe, pseudo-random sort of bit producing thing was written and added to MSK top to allow confirmation of modem operation. Refactored AXI register interface to address register read issues with refactored AXI reads seemed to work okay, but the writes would crash the Pluto, so kind of bad. What he's wanting to do is to experiment and learn system RDL. So he removed the AXI interface and registers, created an RDL description for the registers, and was able to compile the RDL into documentation and into a VHDL module. The simulation of the new AXI/register module is able to read registers, but register writes are not working yet. And he expects that once the writes are working, we can make another build for testing on Pluto. So as you can see, this is actively being developed. There's lots of things going on. The basic functionality we're fairly confident of for the modem, but getting it implemented, that's always a lot of work, no matter what. And for the Pluto as the target, that's what's going on. Okay, so that's the update from Matthew. So he's a conflict, so won't be here today, but we'll see him on Slack later today and in future meetings. Okay, so let me go ahead and I'll just say I've been working to get ready for presentation and running a booth at an event here in the United States. So I'm going to be at HamCon Zion this upcoming weekend, and I'll be presenting about AIML with amateur radio. So sort of the history of artificial life and artificial intelligence, giving some context about how long this has been going on. You know, humans have always been interested in this. So sort of like the recent history of machine learning, LLMs, artificial intelligence, and some case studies of successful and less successful work for amateur radio applications. So that's going to be on this coming Friday. So the slides and the talk itself will be released, and I'll make sure that there's a copy available to all of you. So thank you to everyone that's been helping on the AI channel to make this a good talk and to sort of represent sort of, you know, common sense and useful artificial intelligence and machine learning applications for amateur radio, and helping debug the various things. So it's a team effort, and all of your help has been really appreciated. Okay, so I'm going to hand over the floor to Everest. So please let us know how things are going and what you need.
Okay, hi everyone. Yes, we are working with Matthew and some good development and step forward. So right now, yeah, there is some issue with the writing some registers. That's the first point. And the other is that right now, I can't use IIO to output to TX or even receiving any stream. So I propose to Matthew to have maybe a PRBS or something like that in order to validate that we can discuss between the MSK through the DMA. but this is the second step after we can read and write the register and be sure that all is well initialized in the MSK block. Here it is holidays in France, and so I have less time because I need to take care of my children, but I follow all the development as soon as, as often as I could. Well, that's a point.
Well, thank you so much. We really, really appreciate all of your efforts and your expertise, and understand and wish you the very best holiday, and look forward to whenever you have a bit more time. But I think we'll have to put some effort into catching up with what you've done. Another aspect of your work is the MQTT, to expand sort of the functionality of the transceiver. So what I did is highlighted your work and made sure that folks knew about your repository with the MQTT. Is there any advice or pointers that you can give about that, so that we can dig in over the next couple of weeks?
Yeah, I implement MQTT in order to set up and get status from the DVBS2 block. So on a DATV firmware, there is the documentation. I will give you the link about all the control and status I use on for this MQTT project. The MQTT server is inside the Pluto, so you don't need any MQTT server or broker outside, or you can choose to use another MQTT broker. But by default, it is running on the Pluto itself, so it's the Mosquito project. Yeah, so I will give you the link about all what I implement, and the main target on that is even you can set up all the DVBS2 parameters. You can also set up all the the 9361 of the Pluto, which means that you don't need any IO command in order to set up your frequency, sample rate, etc. It is all done by MQTT, and the process is done in the Pluto itself, which gets the MQTT command and then transfer it to the file system. So not using IO directly, but using the file system with all the parameters and status. With that, you can and even to get input and output IQ stream, or for the DVBS2, it's also transport stream. It is through UDP, and with this method, without using IO streaming, then you can have more bandwidth, because the bottleneck of the IO is the CPU of the Pluto in order to send all the IQs over the network. So I nearly have a solution without IO anymore, but which can be commands outside of, well, you can command it from another PC or else. That's removing the IO dependency.
All right, thank you. That's super helpful, and we'll spread the word and get right on it. So looking forward to seeing this part work. So for those you that don't know about MQTT, we'll include some links and some information in this recording when we edit it up and publish it, so that can give you kind of a foothold. All right, so hey, let's go to Jeremy, and you have the floor.
Yeah, hello there. Can you hear me okay?
Yes, you sound great.
Yeah, okay, great. So a bit of a light week. I did a bit of a write-up of classical PLL theory, and also integrated the changes from, is it Matthew NB0X?
Yes.
So he's he had already written up quite a lot of the maths in the Z domain for the mathematics of what essentially is a digital PLL in our implementation. So I've written a LaTeX document that kind of encompasses all of that, and I've sent it to him, and he's going to have a read through it when he's got time, and we've credited sources and things like that. That's just for my own benefit, more than anything else, just to get up to speed with what's in there. There's some question over what the best approach is for testing the costess loop, and it stems around pulling the costess loop module out and providing it with all its external signals, which looks to be a fairly, it's quite a big job to do that, because of course the implementation already has a lot of the pieces that generate MSK, generate the pseudo-random bit sequences, and handle interactions with the buses. So there's a question about whether to, in order to test it, whether to actually deviate the numerically controlled oscillator inside of the whole implementation as a whole, because that's effectively, I mean, it sounds a bit like the tail wagging the dog, but that might be the easiest way to go about testing properties of the loop, because as I've dug into some of the source code and so on, it's there's quite a lot of work in pulling out the costess loop as a separate thing. On the other hand, writing test harnesses for the implementation as a whole is also challenging, because there's this the FIFOs for crossing the clock domains and so on. The bus has to be driven in the correct way, but saying that, a lot of that's been implemented in the CocoTB test suite. So there's a bit of a question mark around that. I've asked for a walkthrough of, I guess, the current implementation, and I'm hoping that at some point we can have a kind of whiteboard session pointing at various pieces of the diagram and so on, that because I've got some questions about some of the signals in the implementation as it stands. And I'm just wondering also personally whether it's worth me getting a Pluto and trying some of the stuff that you guys are trying in terms of putting it on there. So that's my update. It's not a great deal of progress, but nevertheless, I'm trying to familiarize myself, and I've also pulled down the most recent changes of Matthew, and I'm going to be consuming those in the coming days. So that's me.
Well, that's a lot. So you've raised a number of really good engineering points, and I think that your question about, like, okay, at what level do you test this part for stability is excellent. So you're really on the right track, and I would just go with whatever guidance that Matthew gives you, since he's the lead for this part of the project and the author. So I think and also he has a lot of experience doing digital design in industry. So when we talk about like checking our costess loop for stability, there's a choice right off the bat. Like, do you measure it in the system that it was designed for? Like, do you measure the whole MSK transceiver and your excursions and the things that you are doing to the costess loop are within the limits of the design? Or do you, like you're talking about, taking it out and measuring it as sort of as a standalone? And yes, but well, both of these require a lot of work, but you've raised an excellent point about how much work it is to excise, a block and then test it on its own. Now, that approach is a really good one to put it through its paces within like a test harness and write all that. And it is work, but it's work that gets published, because what we want to do is to publish this as a library of parts. So it's not just a design that we're dumping on the public and saying, here's an MSK transceiver for, opulent voice, but here are all the building blocks that you can use. And each building block really does need to have its own test bench and its own test harness and its own, essentially requirements, specifications. Here's the stability, here's what we can guarantee, and all of that. So all of your work actually is right up the alley for being published in the repository. Which brings up the next thing, is that we're at the point where we're going to move this work to our GitHub repository, so that we'll have a, and there's been some discussion on Slack about like, okay, does every block need its own repo, or do we start a repo that's a library and has lots of different folders? And that's an important thing to decide, and we'll have to figure out the right way to do it. And we may guess wrong at first and have to redo it, and that's okay. But we're starting to move this to a much more public facing repository. So any work that's done to understand costess loops in general is really good work that you can rely upon for many, many years. Like getting this understood and being able to point to that and say, this is work that I did, is valuable. These are at the heart of almost all modern digital communications. And it's also of great benefit to us to have a really solid, well-tested, stable loop. Control loops, need to kind of be stable. And there is a kind of an open question on quantifying the performance of this particular part of the design. We have a lot of confidence that the design works. It works really good in simulation. And as we go through the process of integrating it onto a Pluto, getting it to work over the air, I think we will see that quality. But, if it doesn't work until it's tested, and the testing that you're looking at doing, that's actually super important. So, I would just, again, go back and whatever Matthew recommends, go with it. And yeah, so no, excellent work. And a walkthrough of the design, I think we should probably look at that. I did a whiteboard session and put the photographs of the whiteboard into the Trello card, but that was several versions ago. And then I actually hand annotated the draw IO diagram of the MSK transceiver with all the signals that weren't on the diagram, because I needed them in order to understand what was going on. So it sounds like that would be useful to kind of like go back, make sure that all the annotation and the documentation is caught up with where we are. And I can help with that when I get back from Utah. So I'll be on the road here pretty much for the rest of the week, and I'll be back late Sunday. And then so next week will be I can put this on the list for next week and sort of dig in if that would help. So by next Tuesday, there should be a little bit more documentation to get traction on, and I'm hoping to also by this time next week to be able to say, hey, here's the public repo, and here's the documentation, the README files and all of that, to kind of bring it up to the standard that we need to meet. So I hope that helps. Is there any question that I didn't answer, or anything that's
No, that sounds great. I hadn't realized that there was a bit more documentation in the Trello card. So I'll go back to the Trello cards and have a look there. I've been working from the documentation that's in the MSK repository that's local to the dev machine. One thing that Matthew pointed out is that I would actually have to create MSK signals really to try if the loop were isolated for a test harness purpose. And I'm wondering whether or not there's some MATLAB code that can help in that regard, and where that lives.
Yeah, there's I made a Simulink model to kind of as a transmitter to create the MSK signals because I needed them in order to attempt to do to implement the Hodgart-Massey demodulator decoder in Simulink. And my goal was to kind of use that Simulink model and then make HDL code using HDL coder. So yes, that code exists. It's on Karapi, the VM that handles our MATLAB license. And I think we talked about this a week ago, like last week, and I still owe you the location and to surface that. It's on the MAT account, so you would have to talk to Paul, our remote labs lead, about getting an account on Karapi for the VM that has our MATLAB, and then you have access to that. But I still owe you like here's what I did and here's where it lives. I believe that that should probably be on our GitHub as well. So I still owe you that. I apologize for the delay. But yes, there is at least one good Simulink model, and it shows how you create the MSK signals. And from MATLAB or Simulink, then you can get stimulus files. You can create stimulus files. What I'm doing is just random bits. So I just generate like a Bernoulli random bit sequence, split them into the even and odds the way that the transmitter does, and then do that. So there isn't anything other than random at this point. It's not using our opulent voice frames or anything smarter than just a random stream of bits to transmit. But that model lets you say, okay, I sent this, and then on the other end, did I receive that random stream? So that's kind of the level that design is at. So and there is a good chance that I may not be able to document or surface or properly publish this work before I have to leave for the trip for travel. But so let's just say next week is going to be probably a more likely time for me to be able to share it. I'll do the best I can in the day or so that I have left before I have to leave. But it does exist, and there is a way that we've gotten, and I'll come through and make sure that it's shared and documented, because it turns out it's not bad. It was mainly me trying to figure out how MSK works, because it's delightful and interesting and different. But yeah, there is MATLAB and Simulink code that exists that should meet your needs, and I think next week will be probably the more likely time for getting that to you in a way that you can actually use, instead of just saying, oh, go look at this directory, which that would not be exactly right. I think a good walkthrough and documenting that code would be better. So apologize for the delay, and I'll get on it next week.
No worries about the timing, because I've got plenty to do.
Yeah. There's a scads of stuff to do. It's great. Yeah. Well, thank you for being understanding, and I look forward to sharing it with you, because it's just a really neat design to learn. Yeah, I kind of feel the same way about OFDM, like, orthogonal frequency division multiplexing, a very different way of doing things on the air. So the MSK, very different, not kind of your traditional digital signaling. I've thoroughly enjoyed learning about it and bringing this project to life is going to be a real highlight. So I deeply appreciate your interest and help in making sure that this is a quality design, and I'm just really kind of looking forward to the results. All right, anything else, Jeremy? Anything that you need?
No, I've said what I wanted to say. Thank you very much for your time, everyone.
Oh, sure. No, and I think the last question you had was whether or not you should go to Pluto. I'm very biased. I think you should. I think you should go ahead and get
okay.
it. Yeah, if you can snag one for if it's not a financial burden, then yes, go ahead and get one. It's a really good platform. So I mean, because we have these development stations in the lab, so a really nice 7000 series FPGA dev board, this DC706, and we have a ADRV 9009 attached to it, a really big base station capable RFIC. And then the other FPGA station is a ZCU, it's ZCU 102, and that's a UltraScale Plus from Xilinx. So we have a really big 7000 series, and we have an UltraScale Plus dev board. The UltraScale Plus has a mobile chip on it, so it has the ADRV 9002. Okay, that's great, but like they're not really SDRs in the same way that the Pluto SDR is. So the Pluto SDR acts like a radio, and when it has all of the stuff kind of integrated in a package that was designed for education. So it's a 9361, so an older chip than the 9009 and the 9002, but same ballpark, a lot of similarities. And we're actively using it as a target for the for Opulent Voice. So yes, I would say if you're interested in this sort of work, FPGAs, SDRs, things like that, then the Pluto is a good investment. So, and if there's any way we can help you get one, write me and we'll see what we can do.
Yeah, I think it's looking fairly likely that I will. You very kindly at some point sent me a Lime SDR Mini, but I'm a bit reticent to try and do any kind of porting work, because it sounds to me like it's actually a lot of effort to place these things on a real target, and the documentation is sparse in terms of creating things for or gateware for the Lime SDR, and it sounds like it's going to be a huge amount of work to try and make it work. So if Pluto's the way, then I'll go and pull the trigger on that one.
Yeah, if I had to choose between the two, I would recommend the Pluto, because I think you've assessed it fairly. That the Lime Mini, great hardware, the software environment, and the amount of work that you can leverage, the amount of effort that it would take to kind of do the same things that we're doing is pretty substantial. So yeah, it's good to have, but the kind of the promise on that particular platform, it's further away from what we can kind of take advantage of than something like the Pluto. So your instincts are right, and yeah, I would put money on the Pluto. And yeah, just let us know if it turns out to be out of your budget or anything like that. We would like to help enable people to do this work, and yeah, just let us know. Okay, and I think Ken, you have some reports about the polyphase filter bank and trying to get Linux and the profile working for the ADRV 9009.
Yeah, not a whole lot to report there. We've got I think we reported this last week. It's connected using the TES tool that directly programs the configuration using a kind of like a model FPGA build. So when they give the FPGA file, it'll take it fine. And that spits out a config file that apparently is only useful in what they call a no OS config. I haven't been able to figure out how to bring those files that it only outputs like a C header file and some initialization configuration that it's not clear how it's incorporated with the Linux. So still looking to see if there's any way we can use that, but also trying to go back to the mode where we take the profile that we were kind of loading into TES, and just take that profile and stream it into a profile config, which I guess is the mechanism that you do. You basically write a device file with this profile. And it's sort of taking it, but there is an error message about yeah, I'm not sure if it's a Unix level error or it does. I did try it with some like trivial files and stuff and didn't get the error. So it is something to do with the parsing, something particular about the file. And so I have a query into the Analog Devices help desk as to how to start figuring this out. Yesterday I tried different bits and pieces of that file to see if a particular piece of it was causing the like the syntax error or whatever it's having an issue with, and it's inconclusive. Seems like no matter what I do, if you give it anything that looks like a semblance of the file, it will throw the error. If you give it just complete gibberish, it doesn't throw the error. So that's the state of things. Yeah, but I think ultimately to get the Linux build, we have to figure out a way to go this route, which is basically writing the profile into our live FPGA build and not their kind of standalone build, which is useful for kind of tweaking things. But yeah, that's where we are.
Yeah, thank you. I think that's a really good summary. So made some forward progress over the past week and have a question out because yeah, I couldn't really help with the error messages. At first they looked like the profile was wrong, and it turns out that those messages are in dmessage from the very get-go, right? Like the error messages appear in dmessage before like with the default profile, with the default Linux, everything should match. We shouldn't be getting any sort of profile loading errors at all at that point. And so I think you were the one that spotted it. It actually occurs in dmessage before we even get to the point where we're loading our custom profile.
Yeah, there is a cumulative effect too. If you just keep catting files to this thing and edit them, it seems to save up some, vestiges of the prior attempts. So like I was seeing some errors in that dmessage output that had to do with a trial run where I know I went and hacked a certain section, and it's throwing an error saying, oh, I can't parse this particular thing. Well, it seems like, yeah, it's remembering it. So I had to reboot the system, and now it's no longer giving that error. So I gotta always remember when I'm trying these experiments, may have to keep rebooting it to really get a clear picture from the D message. So.
Wow. Okay. Well, that's very interesting. Well, we'll keep working on it as hard as we can, and we will succeed. And then we'll document everything so that other people that may be trying to do the same sort of work will not have to go through this. So I look forward to hearing what we have either misunderstood or not configured correctly, or what we're missing. It's got to be something simple. Well, thank you. Is there any updates on the is there any updates on any sort of logic? Are you doing any sort of design work or polyphase work or looking at anything else other than trying to figure out the profile problem?
No, not right now. We have a build. I still have a couple of open issues about clock frequencies and stuff, but it should generally work right now.
Okay, thank you. It sounds like if we get this profile problem figured out and we get a good workflow, that we can get back to writing designs and working on the parts of the project that are going to be pretty critical are multiplexing the data. So, getting a number of channels in the uplink and then managing the data and packing it correctly into DVB-S2 frames. That's not done yet, and that needs to be done. But until we can get an end-to-end system, including the profiles and including all of the stuff that Ken's working on, we will not get to the more fun part until we get this infrastructure part sorted out. So yeah, I'm looking forward to fixing that. And thank you for posting on Engineer Zone. If we can get some help there, that'd be great. If anybody's listening to this and any of this sounds familiar, please get in touch. We could use the advice and help. And then let's go to Paul. So let us know how Remote Labs is doing and anything else that you have to report.
Hi. Before I do that, that profile problem that Ken was describing, I'm not sure I know all the data that he's working from, but it almost sounds like the kernel driver is writing the profile out to the disk, so they can save it for later. Maybe I'm just speculating here, but it'd be easy to find out by tracing disk IO during one of these operations and see if it's actually getting saved. If we could find out where and in what format we might be smarter. Okay, Remote Labs. Nothing super new. Just a few little status updates. The replacement SSD seems to be holding in there and working fine, as far as I can tell. That's good news. The dead one that it replaced has found its way back to the USA service depot for Samsung. They accepted in principle that it's a warranty repair, and they've given it a visual inspection and rated it perfect. So next is to run it through some kind of functional test, I guess, and see if they can reproduce my result that the smart report says it's broken. In which case, I think they have to give me a replacement. But we'll see what happens with that. On the performance improvement front, I have a little bit of show and tell. Here in my hand is the PCI card that will contain our 4 new SSDs. And in fact, it already does contain the 4 new SSDs because they arrived yesterday. So this has to go into the server, which will mean some downtime, power cycling and so forth, and then some experiments, which will probably happen next week for similar reasons because of travel. Other than that, the remote lab is as it's always been, and I have nothing further to report. Nothing going on.
Wow, thank you. That's a lot. That's not what I was expecting the hardware to look like. I was expecting something like with an exposed PCB board with connectors and all. Is this a thing where you open the case and then you put the drives inside of it?
Yes, it is. I wish I could hand it to you over the Zoom call because this thing is heavy. It's a lot of metal, and it's all about heat sinking.
Okay.
There's a board on the inside. You can see there's a big fan here, which is a smart controller on board and spins up to keep the SSDs in their, hopefully in their ideal operating temperature environment. SSDs like to run a little bit warmer than hard disks, as it turns out. They get more data permanency if you write at an elevated temperature, but you don't want to get them too hot. So I didn't open it up, but there's like 6 screws on the back here. This plate comes off and the circuit board comes out, and the SSDs mount in the usual way on the back side. This is a big old PCIe card, plugs into a 16-lane slot, which we fortunately have one of free. And then you rely on the motherboard electronics to divide that 16-lane slot up into 4 individual 4-lane slots. Each 4 lanes slot then goes to the individual SSD inside the device. Should be high performance.
So should we see what for somebody that's watching you talk about this cool stuff, what should they expect to see when they log into a VM and try to do work? Like what's the goal of the hardware?
Well, right now what's going on is when you access any kind of disk operation in your home directory or any of the system directories, you're accessing a virtual disk drive, which is a file on an SSD, which is already an improvement over what we originally had, which was a file on the spinning disk array. In the future, we'll have one of two situations, and I don't know which is going to turn out to be the better one. So that's why some experiments are required. In one situation, you will be writing directly to an SSD, which is virtually part of your virtual machine. So no layers of translation involved. And that should only be a little bit faster, but our results with the virtual disk has been that it's kind of slow, and hopefully it'll be a lot faster. And then the other possible scenario is that all four of these SSDs in this new card will be rated together into one giant super fast drive, which promises to be several times faster than a regular SSD by itself under favorable conditions, and probably no slower. And then that SSD would have to host virtual drives to support multiple VMs. So get some speed back and then pay some to get the virtual machine working. The bottom line is that the user shouldn't see any difference, except it should be faster. And if it's not faster, then it's been a failure. Even if it's not faster, it'll at least be bigger, because each of these SSDs is 4 terabytes and the old ones were only 2 terabytes. So you should have more room available per VM and faster.
Outstanding. Okay. So is there anything that you are anticipating in terms of like outages or downtime in order to do the experiments?
There will be. I have to turn the machine off in order to plug the card in, obviously. Once the card is in the machine, then I'll be able to run some experiments without disrupting the VMs. But then to finally integrate into the system, there will be another outage. And I will try to announce those in advance. They won't be this week. They might well be next week.
Okay, well, that's fantastic. And I would just like to say thank you very much for caring about this and continuing to do all of these improvements and to respond to the needs of people using Remote Lab West. So for those of you that are listening along, this is if you don't know about remote labs, this is the way that we try to do our work. And these are remotely accessible lab benches. They don't just have a computing environment for the tools for like Vivado and Vitis and Petalinux and MATLAB and Simulink, but they are connected to, these VMs are connected to a lot of equipment, like all of the development stations that we use for FPGA. The ZC706 with the ADRV 9009 is connected to ChocoCat. There's another VM that has the ZCU 102 and an ADRV 9002. We have also have the Pluto with JTAG, operations on it. You have to modify it a little bit to do the true JTAG. That's connected to Karapi. In the past, we've swapped in and out equipment. So it's not just a remotely accessible computer that lets you run software and have lots of disk space, but it also is lots of hardware. In addition to all of that, Remote Labs has a spectrum analyzer, really nice network accessible, remotely operated spectrum analyzer, a digital storage oscilloscope with the attachment for logic analyzer, and a lot of other things. So frequency counters and power supplies and plenty. Also have a battery analyzer that we've used for the NiCad testing and that project. So that's kind of like when we say remote labs, that's what we mean. And there's a second Remote Labs. It's called Remote Labs South, and we now have a meeting set up with IEEE in Region 5, which covers Arkansas. That's where the lab equipment is located. So there'll be a meeting next week to talk about getting that back online. So the board member that was handling this does not have the time or the bandwidth to support the lab in the same way that we do for Remote Lab West. It's the same set of equipment, and the meetings to kind of sort that out and maybe have this sponsored or supported by IEEE folks in the center part of the United States will be that'll be moving forward next week. So I think we'll be heavily relying on you, Paul, to give advice and to use Remote Labs West model and implementation. So the theory and the design and the implementation of how we do remote work. We're going to be heavily leveraging that moving forward with Remote Lab South. So that's a little bit of update from that effort. And we do have a couple of other labs that are scattered around. So people do have equipment that they're using that's remotely accessible. But the big ones are Remote Lab West and Remote Lab South. So thank you to everybody that supported this and made it possible. We'll have lots more in the next couple of weeks. It may be that I have to travel to support it, the Remote Lab South effort. But if that's required, can't be done. If it can't be done remotely, then I'll let everybody know. And who knows, maybe we'll have a meeting from Remote Lab South in the next couple of weeks. All right. Any comments or any other input, any questions, any resources needed, any other roadblocks or any other reports before we close? Okay, well, if you're in or around St. George, Utah this coming weekend, Friday and Saturday, I'll be there. We'll have an ORI booth at that event, and we're sharing it with DSES, the Deep Space Exploration Society, and making sure that we promote their excellent technical work. And we also will be sharing the booth with QRZ.com. So Dave Jensen will be sitting right by me, so drop by. About a month from now is Defcon. We will be there as well. We'll also be representing Deep Space Exploration Society and all of the other people we collaborate with. And we'll be showing off and demonstrating as much as possible at Defcon. That'll be August 12th and 13th. In October, we'll have our digital update for microwave. That'll be in Vancouver, British Columbia. That'll be week of October 9th. So those are our big events throughout the summer and fall. And our newsletter will go out with a summary of all that we've done in the spring and summer. That's going to go out today or tomorrow. So that's all the updates that I have. And I'd just like to thank everybody for all of their wonderful time and attention and everything that they've done to help promote and support all the open source digital radio work that we do. If you know of a project or a person that could benefit from having sort of a formal structure like ORI, please put them in touch. The rest of the week we have some regulatory meetings and some meetings about some regulatory relief issues. Our FCC dynamic spectrum allocation meeting is coming up here in a little bit, so we'll have plenty more regulatory representation for open source work and amateur radio going on today. And yeah, just thank you everybody for making this a delightful job. All right, see you on Slack.